In the theory of the relativity of time, the times, if they are many, can differ only that the one is slower, the other faster. This is Einstein's assumption. But how are we going to determine the slower from the faster if it's not by the same duration of time? We say, for example, that a body is moving twice as fast as another if it traverses twice the magnitude in the same duration of time. In the same way, a body can age faster or slower than another only in the same duration of time. We can only use the same duration of time for this determination, for if the duration of time itself varied, we could easily make the slower the faster and vice versa. Therefore, differences in the rates or speeds of physical processes have nothing to do with differences in the rates of time. Indeed, differences in the rates of physical processes can occur only if the duration of time is the same. The science fiction that pervades Einstein's theory of the relativity of time, that attempts to determine differences in the rates of physical processes by differences in the rates of time, ignores this most basic principle. In order to posit slower and faster times, it is assumed that time has both rates and durations. But time only has durations, and it is only ever expressed as a duration, a second, a minute, an hour. If we attribute rates to time, every time the rate changes, the duration changes, because a faster time advances a longer duration than a slower one. But the rate can change only if the duration remains the same. Different rates are always determined by a common duration. Therefore, if the rate changes, the duration changes, which keeps the rate the same. These absurdities occur because time has no rate. Time has no rate because time does not move. It is part of the common wisdom of our culture to assume that time moves. We have the often repeated expressions, time flies or time marches on, to attest to this view. In contrast to these expressions, when we measure time, we do not treat time as a motion with a faster or slower rate. Instead, we measure its duration, treating it as an extension rather than as a motion. As a duration, we do not consider time to have a rate or a motion or a velocity. Thus, time is not faster or slower, but longer or shorter. In this way, we refer to a minute or an hour or 24 hours of time. It is not time, but things in time which are in motion and that are faster and slower. A runner, a train, a clock. But time? At what time does time move? Time has no rate. Time does not move. This is why it's possible to have any number of clocks moving at any number of different rates or not at all during the same duration of time. Events also cause us to think that time is moving and even faster or slower. Time seems to fly when we're enjoying ourselves, but drag when we're suffering or uncomfortable. But these aren't the motion of time, but the motion of things or events in time. Though time does not move, we measure its duration by a motion. When we measure the rate of a motion with the duration of time, we are simply comparing the rates of two different motions in the same duration of time. We compare the motion of our standard clock with that of another body. We conclude that in the same duration of time that our clock hand moves a complete revolution, our automobile moves 60 miles. We have by tradition determined that the complete revolution of the clock's minute hand at that rate be assigned a duration of 1 hour. Traditionally, this has been determined with celestial motions. We can just as well use our automobile traveling at a uniform velocity as our clock. In other words, we measure rates of motion in durations of time, while we have traditionally established durations of time with certain motions. But the fact that duration or time exists is not a matter of tradition, only its measure, and we measure it with a movement that has a given rate. This does not mean that time has a rate. In the same way, we can measure distance with a motion. Our car travels 60 miles per hour. In 1 hour, it measures off 60 miles of distance. But this does not mean that distance is moving. Only our instrument of measurement, the car, is moving. Thus, although motion can measure extensions of either time or distance, this does not mean that time or distance are motions. Time is not a motion. It does not have a rate, much less many rates. On the other hand, if we assume, like the relativists, that time has a rate, then it must have a motion. Now, as common wisdom assumes that time moves, it further assumes that it is present time that moves, for the past is no longer with us and the future has not yet arrived. Therefore, if time moves, it is present time that moves. But if present time moves, it would have to move from one time to another. But if the present were in two different times, then either there is more than one present in the present, or the present is both in the present and in some other time, presumably in the past or in the future. To state it differently, in order for the present time to move from time A to time B, it would have to be the same present in both times. But clearly, the present in time A cannot be the same present as that in time B. Thus, either the present cannot move through time, or it can, and therefore the same one present is moving through all other presents, and therefore all presents are the same, that is, the same one time, and everything in the universe would occur all at once. And if, on the other hand, we assume that it is not one present that moves from time A to time B, because then all presents would be the same, is it possible that time A appears and disappears in its present, and then B and C in theirs, and so on, all in their own discrete present times? This is also impossible. First, if time A were to appear and disappear in the same present, since there is no lapse of time in the present, it would have to be appearing and disappearing at the same time, which is impossible. And if it disappeared in another time, then the same one present would have to be in two different times in order to appear in one and disappear in another. Further, if time consisted of discrete, discontinuous presents, then what is to prevent all the presents from appearing at the same time? Clearly, it is only because they are in some sequence of time that this is avoided. But if they are connected to a sequence, then the presents cannot be discrete and discontinuous. Further, to say that the present moves or is in motion assumes that, like all other things that move, it is moving in or through time. Then there is a time within a time, and if the latter time also moves, that is, if time as such moves, then it is also moving in some other time, and so on ad infinitum. Thus all times would be in all other times, and would therefore all occur at the same time. Further, when we say that something moves, we have in mind that it moves over a spatial extension during a time extension. Thus, the body moves over a space in a time. For example, I take a walk around the block and it takes 15 minutes. But if the time, rather than the body, is doing the walking, that is, if the time takes the place of the body as that which moves, then over what does it move and at what time does it accomplish its motion? Clearly, if the time moves over time, it moves over another time, and the latter time still over another, ad infinitum. And if it moves over a space, since any time exists over all of the space at the same time, it cannot move to where it already is. Well, I hope you got through this. Surprised that I did. And thanks for listening, and I look forward to presenting another video. And thank you for your patience. And as Gene Archer used to say, happy days to you until we meet again. Bye.